Side modeling with mathematics here, and a couple things before we start. The first thing I want to make sure that I note to everybody is just to make sure the picture looks a little bit nicer. I changed the set of fives down here to the bottom, changes just to 2. So we'll do our best to ballpark where 1 is and 3 is. It'll be in between, obviously, those locations. Secondly, in the write-up of the problem, the rates for a parking garage are shown. Write and graph a step function that represents the relationship between the number X of hours a car is parked in the garage and the total cost in the garage for 1 day. So we have a mentioning of X hours. A car is parked in the garage. We have the total cost of parking, which is going to be Y value here. But I do want to make sure that I pay attention to the phrasing step function. In this scenario, this is the first time I think this is playing itself out. A step function is a piecewise function with only horizontal pieces. So when I write out the step function in the form of a piecewise function, we're not going to have any slope. This will be horizontal lines, all flat. It will kind of sort of look like a set of stairs, depending upon which way everything's going. And we'll see what that means like here momentarily. All right, so we have daily parking garage rates, $4 for an hour, $16 daily maximum. So we're going to go ahead and I guess try to at least draw this picture maybe first. So we have to enter the garage, obviously. If we don't enter the garage, then we're not going to pay anything. But that first hour, the first hour, of course, we know it's going to be $4. Now, for this problem specifically, let's understand if we're there for 15 minutes, 30 minutes, 45 minutes, anything in between that, all the way up to an hour, it's going to cost us $4. Doesn't matter how many minutes, as long as we're from 0 to 1 hour, it's going to cost us $4. So knowing that down here at the bottom, this is my hours amount, and I know that this is my cost over here, I'm going to go to the location of 4, and I'm going to draw exactly what that looks like right here. Open dot. I'm going to go to the middle. And again, I'm going to call that location 1. That takes in 1 hour's worth of time. No matter where I'm at on that line, it's going to cost me $4. 15 minutes, 30 minutes, 45 minutes, whatever, that is $4. The second hour is 8. Now, that means that once I pass that 1 hour mark, it's going to cost me $8. So unfortunately, if you're there for an hour and then 1 minute, it's $8. An hour and 15 minutes, $8. An hour and 30 minutes, $8. Hour and 45 minutes, and so on and so forth. So now I'm going to go up to the 8th location on this graph. Remember that I can't stack closed dots, so right there is going to be an open dot, and all the way over to the end, hour number 2 is right there. Let's go ahead and make sure we draw a closed dot for that. Now the third hour, you could probably figure out the next set of things as we go along, but that's going to be 12. So that means, again, once I pass the 2 hour mark, everything is $12. 2 hours and 1 minute, 2 hours and 2 minutes, 2 hours and 50 minutes, all $12. I'm going up to the 12 marker. It's an open dot. Remember, we can't stack closed dots. I'm going to go all the way to 3. And at that location, again, draw a closed dot, shooting for the number 3 right there for the hours. Then finally, and I say finally because once I get to after the third hour, once I pass that marker, I know that it's going to be $16. All right, so once I pass 3 hours, everything afterwards is going to be $16. So again, I'll go up to 16. It's right there. That was a big circle. Let's try that again. A little bit better. Let's draw a line. But remember, and this is kind of sort of the key thing here in this situation, it's going to be a maximum of $16. So what this garage is saying is that once you hit this $16 mark, we're not going to charge you anything else. There's not going to be $17 or $18 or $20 or $30 or whatever. We're going to keep that going. Now, in this situation, with the graph that we have right here, this would go all the way. And stay at $16 until we got to the full day. So somewhere off to the side here, I'm going to draw this dot. And just understand that that dot right there is once we hit the 24-hour mark. Why is that? Because once we get to a new day, the clock would start ticking again in terms of being in the garage. So how do I write that out as a piecewise function? As a piecewise function, I would have 4 different pieces. The first piece would be 4, and then 8, and then 12, and then 16. We know that 4 goes up until that first hour worth of time. The second goes up until that second hour of time. The third one goes up until we get to there. And then finally, all the way up to 24 hours worth of time, because then we start a new day, would be $16 for that scenario. In terms of the domain, what would make sense here? It's a full day worth of time. We're kind of focusing on one day. So in terms of the domain and the x value, I have anywhere from 0 to 24 hours in this specific day. I could have my car there for that amount of time. The range is a little bit weirder. We can only have specific amounts, right? So I would just want to consider what the y values are here. 4 and 8 and 12 and 16. This is going to only show itself like this. It's not a compound inequality. It's just we have certain numbers. It appears like this only during a step function. Okay, it appears like that only for a step function. I will take a moment to highlight that yellow so we know that that is step function in this situation. So kind of sort of a weird thing here. You can hopefully see the steps forming in terms of why it's called a step function. We have the horizontal lines for everything.